and good day everybody. Today we are going to learn on square, square roots, cubes and cube roots. Enjoy! (3.1) Square and square roots. What are squares and perfect squares? The learning standard that you need to achieve today is explain the meaning of squares and perfect squares. First, the square of a number is that number multiplied by itself. Example, square of number n is n multiplied by n equal n squared. Second, a perfect square is a number that can be expressed as a square of a positive whole number. Example, P is a perfect square if P equals A multiplied by A, where A is a positive whole number. How do you determine whether a number is a perfect square? The learning standard that you need to achieve here is to determine whether a number is a perfect square. So how can you determine whether a number is a perfect square? First, we can use the method of prime factorization to determine whether a number is a perfect square. In this method, if the prime factors can be grouped into two identical groups, then the number is a perfect square. Let's look at the example. Example 1, determine whether each of the following numbers is a perfect square. Question A, 36. Now, we need to determine whether 36 is a perfect square. The solution is using a factor tree. Okay, we list out the prime factors of 36. Okay, I need you to remember the lesson previously that you already learned on drawing a factor tree. Okay, 36 is equal 4 multiplied by 9. Okay, 4 is equal to multiplied by 2. While this 9 here is equal by 3 multiplied by 3. Okay, this is the prime factor. Okay, if we look at this, 2 multiplied by 2 multiplied by 3 multiply 2 multiplied by 3. These prime factors can be grouped into two identical groups, which is this one. Okay, we can group it into two identical groups. Thus, 36 is a perfect square. Okay, we need to find the prime factorization. Okay, the smart tip for you for this is a perfect square can be written as a product of two equal factors. For example, 225 equal 15 multiplied by 15. 225 equal 15 multiplied by 15, or 15 square. 225 is a perfect square. Example 1. Okay, we go to next example 1B. Determine whether each of the following numbers is a perfect square. This time the number is 54. Okay, this is the B question in your textbook example. Okay, how can we determine whether 54 is a perfect square using this factor tree? Okay, we write the number here. After that, we must find out what number can be multiplied with what number to get 54. Okay, 6 can be multiplied by 9 and we can get 54. Okay, 6 multiplied by 9 equals 54. Next, 6. What number can be multiplied to get 6? 2 multiplied by 3 equals 6. Next, we need to find out what number to be multiplied to get 9. 3 multiplied by 3 equals 9. Okay, we already reached the prime factors here. Okay, which is 2, 3, 3 and 3. Okay, 54 equal 2 multiplied by 3 multiplied by 3 multiplied by 3. These prime factors, okay, these prime factors cannot be grouped into two identical groups. Thus, 54 is not a perfect square. Okay. Next, what is the relationship between squares and square roots? The learning standard that you need to achieve is to state the relationship between squares and square roots. Okay, 36 is read as, this one is read as square root of 36. Square root of 36. Okay, this one is read as square root of 255. Very good. Example 2. Complete each of the following. Question A. 9 multiplied by 9 equal 81. Thus, square root of 81 equal square root 9 multiplied by 9. So, the answer is 9. Okay. Next, B. 32 squares equal 1024. Thus, square root of 1024 equal 32 square. Square root of 32 square, which is 32. Okay, look at self-practice 3.1b. Number 1, copy and complete each of the following. Question A, 5 multiplied by 5 equal 25. Thus, the square root of 25 equal 5 multiplied by 5. Okay, the answer is 5. Great. Question B, 8 multiplied by 8 equals 64. Thus, square root of 64 equals square root of 8 multiplied by 8, which is 8.